I'm actually moving one of the arms of the robot. Flex my wrist, and the hand opens and closes. So signals are being recorded from deep in the muscles of my body. They're being pumped through a series of amplifiers here into some control software. That control software is mapping that to control the arms of the robot. So I can flexibly move, I can control it, open and close the hands, all these nice things. But, okay, why is this exciting? So what am I really demoing here? So what I'm really demoing here is actually all those wiggly lines up there. All right, so the big problem, I said there was an unsolved problem. The unsolved problem isn't really how you connect like 4 boxes to 2 joints on the robot. The problem is how you connect 1,000 little boxes to a robot arm, which is as fancy as our arm, so that you can move at maybe 32 degrees of freedom. That's a really, really hard problem. And there's 2 reasons why this is an unsolved hard problem. One is that control systems don't adapt. I don't know how many of you work with control or optimal control, any kind of control system. Okay, so I've got a couple of hands. So one really hard thing to control is adapting that control, letting control change over time. The other really hard thing is scalability. Like I said, you have thousands of sensors, you have thousands of things that you want your system to control. There's no really clear way to scale things up to that. So we're using machine learning. We're letting machine learning actually learn about an amputee's interaction with a robot arm. So the software that connects all these sensors to those actuators is learning. That's the big idea here that I'm hoping to demo. So what you can see there, okay, good. You've got blue lines happening. You've got red lines happening. So I'm going to hold those up, and okay, you can see there's a blue line and a red line. What's cool here is that the blue line is actually moving up and down before the red line moves up and down. Is that pretty clear right there? So why is that cool? That's cool because this system has been learning about me while I've been interacting with it. So while I've been actuating, while I've been controlling the system, it's been building up predictions about me. And this is a nice tiny piece of software which can expand into a really wide domain. The ability to predict things. Essentially, it learns based on predicting something and then comparing what it sees to what it actually predicted. What does this mean for you? This means that you can actually have systems, software systems, web applications, begin to learn about and build up knowledge in digital form. An actual way to capture knowledge in digital form. And you can actually deploy this with your systems. So I'm gonna start even winding down again and say that. So what else am I showing you here? I'm showing you 2 pieces of software. One is something called. They're both developed by my colleague from INRIA in France. He developed it while he was working here at the USA. One's called RO Park, and one's called Zephyr. For those who are interested, you can actually see the GitHub address right there and download the full software packages if you want to go look at it afterwards. What's RO Park? It's a fully fledged open source Java machine learning framework. And this framework lets you do the same kind of things I'm doing right now. It lets you deploy applications that can learn in real time, can distill large amounts of data. It's got a whole host of different machine learning applications. So that's one thing, and that's what works in the back end here. What works in the front end is what you're actually seeing. That's an application package called Zephyr. It's a way of fusing and visualizing all the data that could be coming in many, many different formats. So you can display multi-dimensional sets of information. You can display any kind of signal you want in real time. It's a flexible package that lets you essentially display information from your application, Java-based application, display data, and be able to interact with that data. So that's 2 things. One thing is happening under the hood, and one thing is happening up here where you can see it. And all of it is helping to control this robot. So what does this mean? What it really means is that in the next couple of years, we're already deploying this kind of software, this hardware with amputees. This is a little toy example here. I like to call this a toy robot because it is. We don't actually use this one with the amputees, but when we're actually working with amputees, we have a much fancier multifunction arm. And in the clinic, we'll be using that. So what's happening here is this software is going to let amputees begin to control and interact with the world much more like we do. So we can actually give control back to somebody who's lost their limbs, upper or lower limbs. I got a minute left, so I think I'm going to stop now and take some questions.